So I'm making this video because number 6 on the homework seemed to be a difficult problem for all of you guys, mainly because of the factorial in the problem. So let me go through some examples on how we can manipulate factorials. So this was number 6 on the homework set. And if you were to use the ratio test on this problem, we would say, okay, the limit as n approaches infinity of the absolute value of e to the 4 times n plus 1 divided by n plus 1 minus 2 factorial times n minus 2 factorial divided by e to the 4n. Now many of you guys saw that, okay, the limit as n approaches infinity, the absolute value. So e to the 4 times the quantity n plus 1 can be simplified into e to the 4n times e to the 4. And the denominator, well, n plus 1 minus 2 is just n minus 1 factorial. We also have this n minus 2 factorial over here, and this e to the 4n right here in the denominator. So we see that, okay, there's an e to the 4n over here, and an e to the 4n in the denominator, so we can cancel those out. But this n minus 2 factorial and this n minus 1 factorial kind of trip you guys up. So, the best way to understand how factorials behave is to write out all the terms. So, if we wanted to know what n minus 2 factorial was, we would say, okay, this is n minus 2 times n minus 3 times n minus 4 all the way down to 2 times 1. Right? That's how factorials work, right? 5 factorial is 5 times 4 times 3 times 2 times 1. So even though it's written weird, it's the same process. N minus 1 factorial or n minus 2 factorial. We start with the number itself, so n minus 1, and we multiply it by each subsequent number 1 less than it. So n minus 2, n minus 3, n minus 4, all the way down until you hit 2 times 1. So if n minus 2 factorial is in the numerator and n minus 1 factorial is in the denominator, what would cancel if you were to divide them? Well, it seems like there's an n minus 2 over here, n minus 3, n minus 4, n minus 2, n minus 3, n minus 4, and everything here would all be canceled out. But the only thing that remains, right, if we divide both of these, would be this extra n minus 1. So this actually simplifies to be the limit as n approaches infinity of the absolute value of, remember this e to the 4 was originally here, and in the denominator it's just n minus 1. So this would be equal to e to the 4th, e to the 4th, let me not write that. Well, if you were to take the absolute value of e to the 4th divided by n minus 1, well, there's an n in the denominator, so the denominator is getting very, very large. So that means a number divided by a very large number is a very small number. So this is approaching 0. And this is definitely less than 1, so our series converges. Another example, maybe for you guys to see as well. Let's say we had n plus 4 factorial divided by n minus 1 factorial. Maybe that. N minus 1 factorial. What would that be? Well, we can do the same thing, right? Let's write out all the terms. Okay, this is n plus 4 times n plus 3 times n plus 2 n plus 1 times n minus 1 times n minus 2, on and on and on. What about the denominator? Well, this would be n minus 1 times n minus 2 times n minus 3, on and on and on. What cancels? we see an n minus 1 over here, n minus 2 over here, and if this is going to behave the way factorials regularly behave, all of the terms afterwards are going to cancel with all the terms afterwards in the numerator. So the terms that remain, the factors that remain, would be the n plus 4 all the way down to the n. So this would simplify into n plus 4 times n plus 3 times n plus 2 times n plus 1 times n. Alright, so if you're ever confused about how factorials are going to cancel, try writing out all the terms first.